Okay, so the question that we're answering in this video is how do we solve this equation for x, and this is an exponential equation, identifiable because our variable is in the exponent. And the method I always go with for solving exponential equations like this is I apply the natural log to both sides. So some of you out there might be thinking, why not just use log base 10 since we have base 10 here? And that would certainly be correct to use log base 10 on both sides. I just am always in the habit of using the natural log. So my way is not the only way. There may be other ways that some of you out there can think of to solve this, but I always go with the natural log on both sides. And then we can use the power property of logarithms. So our exponents, exponent here, both can come down into the front as coefficients. And I always emphasize we don't want to pull out that calculator until we absolutely have to. You might not even need the calculator. If you just hold on and see what calculations you can maybe do on your own. From here, we've got an equation that has two terms with x, and so a good strategy is to get both of those terms on the same side of the equation. So I'm going to subtract the 2x natural log 5 from both sides, or we could go the other way. We could add x natural log 10 to both sides. Either way, it doesn't matter. So let's subtract over here. I'm going to subtract that term from both sides. And then since I have both terms with x on the left side, I'm going to factor x out. And then to solve for x, we would divide by the number that's in parentheses. Of course, in this case, whoops, I made a mistake. This right here should not be an x, that should be a 2. We factored the x out, so this would be divide by 2 natural log x. And I was saying that it doesn't really matter what we divide by here, because with 0 on the right side of the equation, no matter what number I divide by, these go away, but it doesn't matter what number I divide by, 0 divided by any number is still going to give me 0. So I suppose that wasn't too interesting to go through all of that work and end up with 0, but that is the correct solution to that equation.